Welcome to our webinar today on portable generators, backup power for emergencies. My name is Brian Stewart from Electrify Now, and I'm joined by my co-host Shannon Wilson, and we'll be introducing Daniel Uhlberg from Conduit Electric a little bit later in the program. Electrify Now, if you're not familiar, we're a volunteer organization devoted to promoting the benefits of electrification and have really simple steps that people can take. Check us out on electrifynow.net. And this program is also produced in partnership with the LEARN program. It's a San Diego-based workforce education and training program. And we partnered with them to offer these free energy efficiency and electrification webinars. You can find more about LEARN at their website, www.sandiegolearn.com. Okay, so as we mentioned, this is part of a series that we call the Go Electric series, that's all about the benefits of electrification for homes and homeowners. And of course, these benefits include lower energy bills and cleaner indoor air, more comfort, and increased safety in our homes. And it's really the most effective thing that we homeowners can do to lower external air pollution as well as pollution in our homes and dramatically reduce our carbon pollution. So that's why we've devoted this series to this. We have lots of webinars on various topics. And today we're going to really be focused on backup power. And why are we talking about this topic? Well, I think it's top of mind for a lot of people because of issues around resilience and safety and just peace of mind when the power goes off. But we also know that as we are promoting electrification, one of the first questions we get from people is, well, if I electrify my home, what happens when the power goes out? And we want to just make sure give people confidence that there are ways to prevent being uncomfortable in a power outage, and it's not a reason to avoid electrification. So today, we're going to be talking about what the options are. We're going to quickly run over all the options that are available. And I know there's already some questions in the chat about that. We're going to be homing in a little bit on generators, and partly the reason for that is because they're incredible value, and a lot of people don't appreciate that. We've already done some webinars on portable batteries and solar and storage. We'll put links to that in the chat. But we're going to spend a little bit more on the portable generators, but we'll be able to give you a kind of an overview so you know how these things compare. And then we're going to dive in a little bit to what you need to know in order to install one in your home. And I also wanted to say, in case you want to, please let us know where you're from. You can put your name and where you're from in the chat, and we'll be answering questions either live or at the end of the program. So if you have questions, please put them in the Q&A. All right, so I want to start out by just a little bit of a level set, because a lot of people have this preconception that gas-powered homes are more resilient than all-electric homes. And it's not completely true. I mean, and the reason for that is that electricity is needed in a lot of these even gas-powered devices that we have in our homes, like gas furnaces and water heaters, for example, just don't work in a power outage because they need electricity for either the fans that blow the hot air through our homes in case of a furnace, or the fans that keep the air pollution from accumulating in our homes in case of gas water heaters. So both those devices won't work. Your gas stove will work, but you have to be really careful because these things are a major source of indoor air pollution. And if your electrical hood, your ventilation hood, won't work in a power outage, so you got to be really careful about using these. You're going to have to open windows and that sort of thing just to keep the indoor air pollution problems at bay. And then gas fireplaces most likely will work. Some of them, you might have to really fiddle with them to get them to start because they might have an electric ignition. But, you know, the point is that it isn't true that you can just use all our gas appliances when the power goes out. Okay, so what are the options available to us for creating power when the electricity system shuts down? Here they are. That one is portable batteries. There are more and more of these devices available online now. From lots of different suppliers. They're very cool. We've done a program just focused on these, and we'll talk more about these in a minute, but that's one option. Then there are battery storage systems, way bigger batteries. Now, instead of a couple of kilowatt hours, we're talking about 10 to 40 kilowatt hour batteries. These are typically paired with solar, but not always, but typically they're paired with solar. And then there's natural gas generators, which a lot of people are hearing about. More and more EVs are now provide the option to get power from that battery that's just sitting there. We'll talk more about that in a minute. And then portable generators, which again, we're going to go a little bit more detail in that. But I'm going to spend a little time on each one of these, starting with the smaller batteries. But before we get to that, let's just do a little bit of an overview of what a typical home needs in terms of power. How much does our home consume, and what appliances are really the big ones? In general, you could say that on average, a home is going to consume about 30 kilowatt hours per day. This is an average. So you have to keep in mind that if you have an all-electric home and it's cold in the wintertime, you might be using dramatically more than that. If you have a large home, it might be more than that. If you've got a big home in the south during the summer, it could be higher than 30 kilowatt hours. But that 30 kilowatt hours is a rough approximation of an average. And then, of course, there's things we can do when we're in this more survival mode when the power goes out to reduce those loads, which we'll talk about. But generally speaking, there are what's considered lighter loads, and these are things like LED light bulbs, which just sip electricity. They take very little power. So you can see, even if you're running one for 10 hours, it's only 1/10 of a kilowatt hour. They're very small loads. Then you've got things like charging your phones and your laptop, again, small loads. You can even run an air purifier for many, many hours without consuming more than 1 or 2 kilowatt hours. And then our coffee pots now, coffee makers, that has an electric heating element in it that can be it'll absorb a lot, but you don't typically have it running for very long. So if you use it for an hour, let's say, in a day, that's going to consume about 1.5 kilowatt hours. So all of these are, generally speaking, even cumulatively lower than about 4 kilowatt hours. Then you've got these medium loads that are things like clothes dryers, which again, we can avoid using in a power outage. Your refrigerator, which you probably want running because that's going to keep your food from spoiling, but that could be somewhere between 1 and 4, depending on how big it is and how efficient it is. The new modern refrigerators are incredibly energy efficient, but the older ones, can consume more. And then every time we turn on our induction ranges or our, if you have an electric stove, the cooktop, if you use that for a couple hours, you're talking about several kilowatt hours of electricity. The oven, on the other hand, is 240 volts. That thing is going to suck a lot of energy. So you want to avoid using your oven during a power outage, absolutely. And then the other heavy loads are heat pumps, which, again, we're advocating for all electric homes. So a heat pump, if you need it in the winter because it's 9 degrees outside or something like that, and you don't want your pipes to freeze, this is going to consume quite a chunk of electricity. Or if it's summer and it's really hot and you're in danger of, health consequences, you might want to be able to run your heat pump to cool your home. These things are going to absorb a lot of electricity, which is why these solutions that offer heavy load backup are interesting and important in some cases. These electric space heaters, it doesn't matter what kind it is. Some will say they're more efficient than others. Roughly speaking, these things all consume roughly the same amount of electricity. If you ran this thing for 10 hours, you'd be absorbing a huge amount of that 30 kilowatt hour load that we said is average, half of it, just for this one device. And then water heaters, that's another load we can avoid using it. You don't really need to be taking hot showers in a power outage. You could avoid that, but a heat pump water heater is going to be on the low end of this range, maybe 3 or 4 kilowatt hours a day. An electric water heater is going to be 3 times that or more, so it could easily be 10 kilowatt hours. So again, it might be a thing you want to unplug during a power outage. But just to give you an idea of our homes have and how they consume, this is a good way of thinking about it. All right, so let's start with portable batteries. I'm a big fan of these. I've got several of them in my home. I use them for camping, but I also use them in power outages. The prices on these have come down dramatically. For $1,000, you can get a 2 kilowatt hour battery. That's half the price that it was just a year ago. So these things are quite cool and very, they have a lot of advantages. And if you got a couple of them, let's say you get two of these 2 kilowatt hour batteries, because they're heavy, so you don't want to, if you get them bigger than that, they're hard to lug around, but 2 kilowatts, you can carry that. 2 of those, you could charge your phones and laptops, make coffee, you could cook lunch with an induction hot plate or something like that. You can run your refrigerator even if you need to for a little bit, and run an air filter if you've got, maybe it's a wildfire outage. So these things are pretty cool, but it is like camping in your home. This is only running your light loads. You're not running any of those medium to heavy loads we talked about. And then of course you can pair that with LED lights, which are cheap. You can have these pre-charged, and so you'll have light available to you. These induction hot plates, which are also relatively inexpensive, you can plug those into these 2 kilowatt hour batteries and cook yourself a meal or two. There are propane devices that are technically capable of being run indoors, but you have to be really, really careful with these devices. I highly recommend, if you go that route, to get a carbon monoxide monitor to put right next to it, because there are literally fatalities that happen during power outages from people running devices that create carbon monoxide in their homes. But it can be done. All these devices will tell you need to open a window if you're using them indoors. But there are heaters, small little heaters. They're quite inexpensive. And of course, propane stoves. So this is like I said, you need to have the mentality of camping in your home, but you can get by. And I've done it for many, many days with this solution alone. Okay, and then there's the more, this is more widely adopted solution. That's more and more people are doing this, typically paired with solar, as I mentioned. These battery storage systems now, instead of 2 kilowatt hours, you're talking about 10 kilowatt hours for one of these. That's the typical size. And they generally speaking, cost around 10 grand for one 10 kilowatt hour battery, including installation after the federal tax credits. Okay, so these things, and that's a budgetary number. It's going to be different from place to place. Most places will insist on from my experience, will insist on installing 2 as a minimum. So that's about 20 grand. And if you want to be able to run some of these heavier loads we were talking about, like a heat pump, you're going to need 4 of them. It probably minimum, because that heat pump can just chew through this capacity really quickly. So I would say these things are great for medium loads. Absolutely. Light and medium loads, no problem. If you have a heavy load, you can run it for a shorter duration. If you're in a sunny place, if your power outage is in the summer, your solar system might be giving you another 10 to 15 kilowatt hours a day to recharge some of this capacity, but unlikely you're going to be able to keep up with your demand from that. And if it's winter here in Oregon, for example, there's no way that your solar system is going to recharge your batteries as you're using it for these heavy loads. So as I said, I love this solution, but you just have to be aware that this is not going to be able to power your heat pump for many days, most likely, unless you're able to recharge. Okay. The next solution that a lot of people are familiar with are gas generators. These things are great from the standpoint that they can power your whole home. They'll turn on automatically. You don't really need to worry too much about loads, because it can drive everything. In fact, here, when the power goes out, our neighbors have their Christmas tree lights going. So, and their outdoor Christmas lights going. So, these things can handle the whole load. They're not cheap. They're going to start probably at around 12 grand. And depending on your home, they could be as high as 25,000 if you've got to put in a propane tank because you don't have natural gas. That's even more expensive. But generally speaking, they're in that 12 to 20, let's just say, range. The major problem with these things, and the reason why I do not recommend them to anybody, is because this is just not compatible with a fossil fuel free future. It's not. I mean, what we're doing is we're perpetuating the gas system by wiring these or plumbing these things into our homes. So I'm really not a fan of these, even though I appreciate that they offer a lot of convenience if you can afford them. All right, so then the other solution, EV to home. This is a super exciting one. It's kind of emerging at the moment. Not all EVs are capable of doing this. But look at this, for example, 60 to 130 kilowatt hours. That's the typical battery. If you any car that has a 250-mile range is going to have at least a 60 kilowatt hour battery. It's probably more like 70 or 80. And some of the larger pickup trucks are as much as 130 or larger even in terms of their battery size. So remember we were talking about a home solar storage. They're like 10 kilowatt hours for each battery, 10 grand each. You've got, you know, multiple times that sitting in your driveway that you've already purchased because you're using it as a car. So I love the dual value that you get out of this EV to home thing. There's kind of two ways that we can right now we can get power out of our EVs. One is called vehicle to load. It's often called V2L or referred to as V2L. This is basically like running an extension cord from your car into your home and having a power strip on the other end of it. Think of it as like one circuit, one 120 volt circuit. So it can't run your whole home with this method, but you can definitely drive all those light loads we talked about, and even some medium loads, like you might be able to run your refrigerator, et cetera, on this. It's essentially free. I just learned yesterday, a friend of mine bought a new Hyundai, and this adapter that you're seeing here in the picture came with the car, where you plug this into the charge port and then literally plug an extension cord into it that you can run into your home. Or if you have to buy one of these, they cost around $200. So this is a cheap solution to give you a lot of power for a standby. Again, it can't run a heat pump, but it can do a lot of these other things. Then the more kind of deluxe version of EV to home is what's called vehicle to home, V2H. And only a few cars are capable of doing this at the moment. The Lightning, the Cybertruck, and Silverado, these pickup trucks can do this. There's a law that just passed in California that's going to mandate that all cars have some kind of bidirectional charging capability in the future. But this is still coming online. Volkswagen is promising to be able to do it. Tesla is saying that their cars are going to be able to do this in the future, which is exciting. But basically, you need more equipment. You need a transfer switch and a way to connect this big load which is now 240 volt circuits and 40 amps. It's a lot of power. You can get in and essentially run your whole home for several days. And the thing that's great about this option is, let's say you've got a long power outage, like a week. Well, you use as much of that battery as you can, keeping your eye on it so you don't use it all. Drive it somewhere to recharge, because it's highly likely that within 20 miles or so where you are, you're going to be able to recharge your car and come back, and now you've got several more days worth of power. You can't do that with a stationary battery system. That's just why this is a really exciting option. It's just not widely available quite yet. Okay, so then that brings us to portable generators, which we're going to go a little bit deeper on. These things are relatively inexpensive. On this, a lot of the things we've been talking about are tens of thousands of dollars. This is more like 2 to 4 for really a system that can power your whole home for several days. It can handle these heavy loads that we're talking about. Yes, you are burning fossil fuels with these devices, but it's only for a very short period of time. So from a systems-wide decarbonization standpoint, this is a pretty good stopgap solution until our EVs are even more available in order to power our own home, is the way I think of it. And we're gonna dive into these a little bit more. Well, I've put together this fact sheet, and I'm not going to spend a lot of time on it today, but we'll put a link to this in the chat where it compares these 4 or 5 options that we've talked about, how they compare on cost, et cetera, what they're good for, the pros and cons. And as I said, I'm not going to spend a lot of time on them, other just to point out that, if you're talking about whole home backup for heavy loads for a long time, the only options that are really available to do that are gas generators, the EV, the few cars that can do this EV to home, vehicle to home, and portable generators. The other ones are not quite so, it's just not possible to drive your heat pump for many days with those solutions, if that's important to you. If that's not, then these other options are really great. Okay, let's go into the portable generators a little bit more detail. What do you need? Of course, you need the generator itself, and we'll talk more about what you should be looking for in these. But generally speaking, there's lots of manufacturers that do these. They run from about $1,000 for one that's big enough to run a whole home to up to $3,000. You need one that will put out 50 amps and has, we'll talk more about this in a minute, but generally speaking, you need at least 7.5 kilowatt hours of capacity. And you're probably going to want more if you're running a heat pump. You're going to need fuel for them. They're going to run on either gasoline or propane. Some operate on both. Some you can also operate on a natural gas line, but of course, as we mentioned, we want to get away from that. So I wouldn't advise that. You need a big fat cable to connect to your home, to the power, to the generator. And then you need to do some wiring on your home. You need this inlet box on the outside of your home, because these things have to be outside. They're noisy and they create carbon monoxide that you just cannot have inside. Even inside a garage, you cannot do that. So this needs to be on the outside of your home. You need that separate dedicated circuit that goes to your electrical panel, and you need an interlock switch. It's called, basically what that means is this generator will be powering your panel if your panel is disconnected from the electrical service, because you do not want, it's illegal and it's really dangerous to be driving power back into the electrical system. During a power outage, you could electrify an electrician who's there fixing our wires or something like that. So it's super important that you have this, and we'll talk more about that in a minute. But these are the components. Obviously there's lots of options available for different kinds of generators. Again, I'm not going to spend too much time on this. This is in that fact sheet that we have available to you. It's on our website. It's also, we'll put the link in the chat. We'll send it out to people who registered. You can see that there's lots of different manufacturers. The one thing I want to point out with here, again, they range from about $1,000 up to $2,500 or even more. You can see these two on the right are different from the others because they're called inverter-driven generators, and we'll talk with our panelists about this in a minute. But essentially, that means they're quieter, and they have some other advantages, which we'll discuss. So that's one thing that makes some of these more expensive than others. And if you live in California, you want to be really aware of the fact that only some of these generators are legal to operate in California and even purchase in California. They're CARB compliant, it's called. So I should have capitalized that. That's California Air Resource Board. So there are some differences like that, but again, you can see there's lots of options that are all in this. I've just picked the ones that are roughly speaking in this 10,000 watts of capacity or greater. And again, you can get them quite large. Okay, so that's the overview. And now we're going to dive into like some real meaty questions with our guest panelists today. I'm really excited to have Daniel Uhlberg from Conduit Electric with us today. Daniel's a journeyman electrician with Conduit, and he's got all the licenses that he needs for that. He served as an estimator and also a project manager. So he really knows the ins and outs of a lot of these things that we're talking today, specifically around home backup power. He's a big fan and sort of like a aficionado on all things electric. And he has this particular interest in electric cars, energy generation at home, and energy efficiency and reducing consumption. So his company has installed a lot of these things we've been talking about today. So he's kind of a perfect guest for us today. So Daniel, welcome to our program today. And maybe just as a little starting point here, why don't you tell us a little bit about Conduit and your background and your experience with installing these systems?
Thank you, Brian. So yeah, I'm Daniel with Conduit Electric. We're a small family-owned business based out of Tualatin, Oregon, and we serve the greater Portland metro area. Yeah, I mean, we're capable of providing any electrical service you can think of to your home or to your business. And lately, we have been getting a ton of attention as far as generator installs. Within the past, I say about 5 to 6 years, our area in particular has been hit by pretty substantial ice storms that have knocked people's power out for several days, or in some cases weeks. So this has been a very popular topic of discussion around my business within the last, like I said, handful of years. So it's a really great value. I mean, the battery backup system is awesome as an alternative too, but when it comes down to what the most popular install is for us by far is going to be these portable generators, because it's a relatively low cost to get this hooked up to your home. And as long as you don't have a crazy expectation as far as how much electrical use you need to sustain you during an ice storm or a power outage, whether it's summer or winter, you're going to be able to run your house off of this generator pretty comfortably in many cases. So a lot of people, this is actually a somewhat new technology. Kind of in the past, that what was really popular was what's called a generator transfer switch panel, which basically makes you choose, usually give or take around 8 circuits to feed, while the rest of your house circuits are out. But nowadays we have these interlock kits, which basically allow you to separate your home from the utility, so it's safe to backfeed your home with a generator on site, and then you get the benefit of being able to power everything. You don't have to
Yeah.
pick and choose anymore. So
Yeah,
it's
that's great. So you install natural gas generators and these portable ones, correct?
that is correct. Yeah, we can do standby generators. Those are typically going to be starting at around the 14,000 kilowatt ballpark. And to be clear, those are the stationary variants that are automatic, and those are the ones that are starting at around the $12,000 to $25,000 figure that Brian put up in his image. And we can also do, like I said, the portable style, which typically is going to be around 7,500 watts up to about 12,000 watts as far as what they're capable of outputting in. And that's going to be a gasoline rating, because that's another little nuance is basically the more convenient the fuel source is for these generators, the lower the wattage that they put out is, with gasoline being the highest, propane being the middle, and then natural gas being the least powerful gas. But in general, you're still okay to operate even off of just the natural gas, because I mean most people see all these breakers in their panel, and they get all nervous about being dangerous to have a small generator that's putting out nominally about a 30 amp circuit or 50 amp circuit for the
Yeah.
larger
Yeah.
style. Yeah, but in reality, the average house does not use that much power concurrently, which is really the name of the game with these generators. Is you're basically going to be able to run anything that you want, but you can't necessarily run everything at the same time. That's honestly the main takeaway as far as energy load management.
Yep.
So Daniel, can you tell us a little bit about the pros and cons between the portable gas generators and the natural gas or methane generators?
Yeah, so the biggest pro is going to be the value proposition, because as we already discussed, you have, roughly, if you have a budget of like, I'd say around 2,000 at the best case scenario, up to about 4,000 to 5,000 at the worst case scenario, you're going to be able to set your house up with a portable system. Now, if you're going with the standby system, you're looking at a cost of approximately, we'll just call it 3 times the cost. It's just a rough estimate. And really the only benefit, well, the main benefit of having the backup system, like the standby system, the automatic standby system, is you don't have to be home to run the generator, because the portable systems, that is one catch, is you have to be on site to be able to do the transfer and to start the generator. Whereas one of these standby units, there's nothing you have to do. There's no work. It does all the work for you.
Yeah, it's true. And I think, in my experience here, you have to like wheel the generator out, you have to connect it, you have to go through those steps of the interlock and everything. We'll talk about that in a minute. So versus the fully automatic thing that just happens as soon as the power goes out. I mean, my estimation, I'm happy to save $10,000 or $15,000 for having to go through those steps, but it is true that it's not quite as slick as the automatic transfer thing that happens. But tell us a little bit about the wiring, Daniel, and this interlock. Say a little bit more about this interlock thing, because I know that's probably a little bit a new idea for people. Most people probably haven't heard of that.
Right. So basically, the procedure to actually do the work is to basically, you just have to install the circuit breaker that the generator is going to backfeed your panel with, and then you got to run the circuit from the panel over to the location where the generator is going to be operating in, which is that needs to be on the exterior of the house because of the danger of exhaust fumes. And that's really the whole procedure. It's quite simple. It's a very low cost and low impact install for the most part. Now, the one thing that I will say to qualify this is that you do need to have what's known as a main breaker on your electrical panel in order to make this happen, because without the main breaker, you don't have any way of disconnecting your home electrical system from the grid supplying your home. So the picture that Brian chose for that interlock kit in his presentation, that did include a main breaker style panel with an interlock, of course. So if not everybody knows if they have a main breaker in their panel, that's pretty much the main thing to consider. An easy way to tell is if you go to your electrical panel and if you see a large breaker, typically going to be noticeably larger than the other breakers in the panel, serving outlets, your water heater, your car charger, what have you, it will typically have a much larger breaker that will have, say, a 200, a 150, a 125. See, that's a great example right there. That's a 200 amp main breaker panel, which is going to be the standard electrical service installed in homes today. Older homes commonly will have smaller services. I'd say around like the mid 70s to the early 80s to present day is going to be most commonly served by a 200 amp service. And really, if you don't have a main breaker installed in your panel, in just about 99% of cases, my recommendation is to just replace the panel, because having a main breaker panel is definitely a huge safety advantage.
Yeah.
To be able to rapidly disconnect the power feed from your home should an emergency arise. But furthermore, the electrical panel life expectancy is probably expired by that point, because if it's that old, it probably is going to be in excess of 30 to 40 years of age. So I would recommend most of the time to just replace the main panel so you have a main breaker set up. And there's another option, which is to do it's a sub panel, which is kind of like a glorified version of that transfer switch panel that I mentioned earlier, like from yesteryear, I'll call it. They're still available today, but we haven't installed one of those I don't believe I've even installed a single one of those in my time as an electrician.
I mean, this is a really slick solution, because this is just so people understand. This is the main breaker here, so you can turn off the whole panel up here. And essentially, what this little mechanical thing is doing is that you can't turn on the breaker to the generator, which is this one here, unless the main breaker is turned off. So then you can slide this thing up and turn the circuit breaker on for your generator. So that means that there's no way that you can have your generator putting power into your panel and have the main breaker on. So it's, I don't know, we don't need to go too deep on this, but it's a pretty ingenious little device that that makes this kind of relatively inexpensive to connect to the main panel.
Yep, exactly.
So if someone's thinking about getting a portable generator, what are the critical features that they should consider when they're choosing one?
Yeah, so the most important thing to do is to identify how much power you need, which in general, I would say if you have high efficiency electric appliances like a heat pump, like a water heater, a heat pump water heater, or a heat pump dryer even. I mean, for the most part, and also LED lighting, that's worth mentioning. LED lighting is very helpful as far as cutting the amount of power that a house needs. In general, you're going to be able to get away with a smaller, nominally that's a 30 amp or about 7,000 watt of output of generator. But if you have, like, for example, if you're on well, if you're not on city water supply, if you're on a well, I would recommend against going with a smaller generator. You want to be looking at a 50 amp generator. At that point, that's definitely a big consideration. And then also, if you have like electric resistive heat strips in a furnace, like supplemental, emergency heat, for a heat pump system, that's going to be something that in many cases a portable generator will not be able to power. If it's a 40 amp circuit, that's going to be okay. But if it's more commonly, you see those in 60 amp circuits, maybe even two 60 amp circuits, that's not going to be something you're going to be able to run on a portable generator. That's an important distinction to make. So basically anything that's like a 40 amp breaker or less, you're going to be able to run off of a 50 amp generator without issue. So yeah,
Yeah, you know,
if you have actual,
it's interesting. I mean, I noticed when just shopping around that it didn't seem like there's a really big difference in price between the smaller generators and the bigger ones. I mean, once you get up to anything like going from 7,500 watts of output to 10,000 watts, it's generally maybe you might be a couple $100 more. So it's not a huge extra expense to go to these bigger ones. You can go to the really big ones. It feels to me like the impracticality that you run into is they get really big. They get giant. Like you can get a 20 kilowatt capacity generator, but this thing could weigh 300 or 400 pounds once you put fuel in it. So it's a little bit dicey to be moving that around. But in general, it feels like it's you might as well go for like the 10 kilowatts because 10,000 watts, because it's not going to cost you a lot more. And then you'll have the capacity you need.
Yep, that is definitely true.
Are there any other features that are really critical? Like what's the story with, tell us a bit more about inverter versus non-inverter generators.
Right. So yeah, when you're shopping for generators, you'll see some models that are marketed as inverter style models, which basically what that means is an inverter is going to make the operation of the generator be substantially quieter than a non-inverter model. And also inverter generators will be able to provide a cleaner sine wave power source for your home, whereas a non-inverter is going to be a lot more reactive as far as like a sudden load. Like if you're running at say like 1,000 watts of consumption on a non-inverter model, and then all of a sudden you turn on say like a couple burners, you start making lunch, let's say you turn on some burners on your cooktop, or you might turn on the oven, and then all of a sudden your usage spikes by a couple thousand watts. Well, the generator is going to need to compensate for that, so it's going to increase how hard it works. And sometimes what that can do is that can cause a little bit of a voltage discrepancy where most appliances aren't going to be phased by that, but some more sensitive electronics can be phased by that. So basically, the inverter the inverter generator is going to, it basically has a battery for all intents and purposes that will smooth out the sine wave and the alternating current that it produces for your home. So the loads they're not subjected to that variation in
which
usage.
is probably a good thing. I mean, and just on the quieter thing, this is not a significant difference too. I mean, it's like 10 decibels quieter in general for the inverter ones, and that means half the noise. So it's a significant difference. If noise is an issue for you, if you've got it far away from your house, maybe that's not so much of a problem. But if it's close to your house or next to your neighbors, that quieter ones, I recommend them because it's noise pollution's just out of control anyway. I'd like to, the 65. Basically what the audiologist people will tell you, anything over 70 dB is starting to get into dangerous territory. And these things, even on a half, they're that spec you see that I showed you on those charts, that's not at full power. That's at like quarter to half power. So when they're really revving, they're going to be noisy. So I like the inverter ones from that standpoint. It's a significantly quieter rating.
We've gotten a few questions about weather protection and whether portable generators can operate in the rain.
Right. So the number one thing to do is to observe whatever the manufacturer's instructions for operating the generator. However that is, whatever they say, that's you have to abide by that. But in general advice from me is to do not subject your generator to snowfall, to rainfall, to an unlevel platform. If you can put it under cover or even just under like an eave, that would be very, very helpful to the generator. And it doesn't have to be perfectly level, but it's a wise decision to try to make it as level as possible when operating.
So is the issue with rain, for example, is that some kind of electrocution hazard or something like that, or is it just more like wear and tear on the device?
I think it's more wear and tear on the device, just keeping things dry. You know, things that ought to not be wet. You know, they want to keep them dry, and you know the generators are not sealed units; they're not enclosed and all that. Believe it or not, I mean some of them can be, but in general, you're not going to have a generator that's designed to just be out in the open, just getting rained on or getting snowed on. So,
And then related to that, there's someone had a question about maintenance of the generator. If it needs to be run every few months or what else it might require.
yeah, so I think that they usually in general what they recommend is probably about 300 to 500 hours of like an oil change interval. I mean, it's another engine, so it's one more thing you got to maintain as far as spark plug, as far as air filter, as far as oil, you know, all the typical things to maintain on an engine that's going to apply to a generator. And once again, they will have all the service interval recommendations in the instructions, but I think general rule of thumb is 300 to 500 hours.
Yeah. Okay, let's talk a little bit about, things you can do to reduce your electrical loads in a power outage. Because if you're going through this process of connecting your generator, flipping those circuits and all that kind of stuff, you're engaging the interlock, you're standing there in front of your electrical panel anyway. So, what would you advise people to do just to make sure that you're not overloading your generator?
Yeah, so the main thing would be to identify any circuit breaker that your generator just cannot support. By far the most common is going to be, like I was mentioning earlier, like the resistive heat strips for an electric furnace. There are very few generators that are going to be able to support that, especially at least of the portable variety. A standby natural gas like pad mount generator that's automatic, that will be able to handle those in general, or at least one of the heat strips. Sometimes furnaces have two, but that'd be the first thing is to just shut off anything that your generator is incapable of powering. And outside of that, it's really going to be the number one energy consumers in a home is going to be anything that manipulates temperature, whether it's cooling or heating. So you can make an effort to reduce the amount of power that your generator ends up having to provide if you can basically you can turn the thermostat up when it's a time of cooling, or you can turn your thermostat down when it's a time of heating, and make sure that everything is sealed up tight. You don't leave windows open, you don't leave doors open. It's an intelligent decision to make sure your home is insulated and sealed as well as it can be. That will save you energy in operating your climate control system in the first place, but that'll additionally help your generator to use less power, therefore use less fuel, and extend your time in between fill ups. But I mean, the average house, as far as lighting goes, as far as outlets go, there's really not much consideration I personally would have. It's really just the main appliances, and I guess you also have like water heaters. Water heaters are going to be doing about 5,000 watts concurrent, so that's same with an electric dryer. This these are non-heat pump models that I'm speaking of here.
Yeah.
And 5,000 watts is going to be the lion's share of what a smaller generator can provide. So
Yeah. So I mean, if you turn those breakers off, then you're likely not going to overload the generator when your heat pump kicks in, because you don't want those things happening all at once, right?
right, exactly.
I mean, this turning the temperature down thing. I mean, I've read that it can be as much as 1 to 3% for every degree you like. If you in winter, if you turn your thermostat down 1 degree, you're saving somewhere between 1 and 3% of the energy use in your home for the heating. So it's a big deal. If you turn it down 10 degrees, let's say, you're going to get, you're going to substantially reduce the load on your heat pump, which will either make your generator operate longer because you're using less fuel, which is a good thing, or, keep it from working so hard in the first place. Yeah.
Right.
So we've had a couple people suggest using a small generator to charge some portable batteries as a way to maybe do a hybrid solution.
Yeah, that's certainly an option too. I mean, there are plenty of portable batteries that are basically like a generator substitute these days, where they have a 240-volt output right on them, and those ones will, I believe, they typically start at around 5 kilowatt hours, and they can go up from there. A lot of them are gangable, even, so you can expand it as you need. And yeah, I mean, that's definitely an option. You could.
Daniel, have you installed any where people are using a portable generator to recharge their solar storage batteries? Is that a thing?
So in the way of solar storage, no, but we have had a singular customer in the past. Recently, it was too. He had us install um, a smart transfer panel that was designed to operate with a battery system. And additionally, he also had us install a generator um, interlock system on that too. So he could have it both ways. He could have it so that the batteries are charged by his generator, or he can have it so his whole home is operating off of the generator when the batteries go out. So he's kind of got a dual redundancy system, and there's nothing wrong with doing it that way. It's just one more system that you have to manage, and you have to be cognizant of the battery level, and then you have to start the generator up and then plug it in, and operate it that way. So
Yeah. I see there's a question here about how big does a portable battery need to be to run an induction cooktop during power outages. What I've seen is the 2 kilowatt hour batteries generally are going to give you enough amperage, enough output to run a coffee pot or something like that, or an induction cooktop, induction hob. But if you get, less than that, they may have enough power, but they are enough kilowatts, but not enough amperage. So you might not be able to run a coffee pot or an induction hob. So I'd say in general, if you're in this 2 kilowatts hours or larger battery, most likely you're getting enough power output to run these little devices we've talked about. Not the big loads, but the cooking and things like that. Shannon, you see any other questions that look interesting here?
Well, someone was curious about how they could find someone to set up a portable generator. So I was just curious if someone were going to seek an electrician to help them out with this, what questions they might ask or what skills they might look for or experience.
Yeah, probably the first thing I would do is to just ask them how many systems they've installed, or just the basic questions, just to see if they're familiar with it. Not trying to gatekeep or anything, but I mean, it is an important thing to make sure that you're choosing a competent installer that's familiar with this, because you can have things go sideways if you have an inexperienced installer. Yeah, it's probably the main thing is to just ask them what systems they've installed in the past. It's probably the main thing.
Yeah.
Yeah.
And there's a question here about portable generators large enough for commercial applications. I mean, we've really been talking about the residential sizes. I'm sure there's bigger ones, but are you familiar with that, Daniel?
Yeah, I haven't been personally involved with those in the past. My company has, though. there's a server farm effectively that we installed about 15 years ago that had a tremendous uninterrupted power supply that that fired up right away in the event of a power outage, and it kept the system running long enough until the standby diesel generator was able to take over, and that basically had a semi truck engine, and it was on a 1,000-gallon diesel tank out in the parking lot. So that was something that we have had experience with in the past yet.
Shannon, you see any questions you wanted to pick off there?
There were a couple questions about propane versus gas diesel, maybe using different fuels, generators that use different fuels. Yeah, a dual fuel portable generator. So some people are just asking about the propane option.
Right. So basically, every portable generator is going to be compatible with gasoline at the least. When you see a dual fuel rated system, that's going to mean gasoline and propane. And when you see a tri-fuel system, that's going to mean it takes gasoline, propane, and natural gas. And there's a control right on board where you have to manually select what type of fuel you're providing. So you can't really screw it up as long as you just follow the instructions. But yeah, the main takeaway with that is that the higher the more convenient the fuel, the lower wattage it's going to produce. And you can expect, say, if like a 7,500 watt on gasoline generator is probably going to be providing about 6,800 watts to 6,500 watts on propane, and then on natural gas it'll be closer to probably 5,500 watts. So
yeah,
there is a bit of a stair step.
Yeah, and I guess one of the nice things about propane is that it lasts longer, right? Like if you have gasoline, you can put additives in that prevent it from going bad, but in general, you don't want to be storing that for too long. Whereas propane, you can store relatively indefinitely, isn't that right?
As far as I know, yeah.
Yeah.
I personally have not heard of propane going bad. It's good for many years. So
yeah. Well, I think we're doing pretty well here. I mean, I think there's a question here about running your generator. What if you don't use it very often? Is it going to be ready when you need it? I think it's always a good idea to turn it on every once in a while just to make sure. Like for us, here in Oregon, I'm sure it's different everywhere, but in Oregon, the power outages, they're really problematic, happen in the winter, and they're coming. You can see them coming. So in general, but I think it would be wise in December to maybe get your generator out and fire it up, make sure it's working, make sure you've got all the fuel that you need when the power outages are likely to happen in December or January or February. But of course, if you live, if it's hurricane season or something like that, same thing, you would want to be, it's one of the things you should be doing to think about getting prepared, I would say. We should probably wrap it up here. There's quite a few questions about vehicle to home and all this sort of thing, and I'd love to dive into that, but I think we're going to devote a separate webinar to that topic because there's lots to unpack there. And it's the thing that I'm really the most excited about of them all. I consider these portable generators to be a sort of like stopgap until our cars are more capable of doing what we want them to do, and it's not far away. But for most people, it's not quite ready yet, unless you have one of these really big pickup trucks. But we'll dive into that more probably in the new year, and as things develop there, we'll keep you posted. So Shannon, any last questions or thoughts before we wrap up here?
No, I don't think so. Yeah.
Well, good. Thank you everyone for tuning in today. Daniel, thanks again for your time and expertise here. It's been really helpful. And if any of you have questions that you really wanted to get answered that we didn't cover today, because I know we can't answer them all, feel free to email us. Our email is on electrifynow.net. You can find us quite easily, and we'll try to make sure your questions get answered. We'll share the recording and the presentation materials, this handout that we mentioned, and any other links that might be helpful to people. We'll put that either in the show notes on YouTube, or we'll send it out to everyone who participated. So thank you very much, and good luck with all your electrification projects, and hope to see you at one of our upcoming programs soon.